Welcome students. Today in kinematics we will be studying distance, displacement, average velocity, instantaneous velocity, average speed, instantaneous speed, average acceleration, instantaneous acceleration, and motion in straight line. Okay, so let's start. Distance, and displacement. So to understand distance and displacement, let us draw a coordinate. This is time axis and this is distance axis. Let a particle move from A to B. Let us join these points with the origin. Point B. Now distance is length of actual path traveled by the particle. Okay. If you join these 2 points A and B with a straight line, then it becomes vector AB. And displacement is length of straight line joining initial and final position of the particle, that is AB. Okay. I think it is clear now. What will be the displacement in this case if this is R1 vector, R2 vector, it will be OA plus OB, AB OC vector. Hence AB vector is equals to OC vector minus OA vector. Okay, which means R2 vector minus R1 vector. Okay. So now we understood what is the distance and what is displacement. Displacement is the straight line, length of the straight line joining initial and final position of the particle, whereas distance is the path, length of the path actually traveled by the particle. Okay, let's go to the next page. Now what we will study? We will study average speed and instantaneous speed. Average speed and instantaneous speed. Every one of you are aware what is speed is. Speed is equals to distance traveled over time taken. Now again draw the coordinates with origin O, A point, B point, OA vector, OB vector, this is again distance and time curve. Suppose the particle travels from A to B from time t1 to time t2. Then average speed is equals to distance of the path upon time elapsed, that is t2 minus t1. Now if we want to understand instantaneous velocity, then take a point on this path. See here, suppose this is a point. At t, and then another point at t plus delta t. Then instantaneous speed is equals to delta s, that is distance, small distance divided by small time. Now if we make this delta t tending to 0 and taking limit, we get limit delta t tending to 0, delta s by delta t. If we reduce delta t equal to 0, not exactly equal, it is tending to 0, then we will be getting the speed at this particular point. When delta t is small, then this this point, the second point at t plus delta t, will coincide with time t is equals to t, right? So this can be written as ds over dt. Now you got it. This is what speed and instantaneous speed is there, right? Now next page. Now what we will study? Average velocity and instantaneous velocity. Now again we draw a coordinate. This is displacement and this is time curve, right? Let's again take 2 points A and B, and the origin then average velocity is equals to displacement upon time taken. Suppose the particle is having a velocity VA at time t is equals to t1 and B at t2, then we are going to measure A and B, that is the straight line between positions A and B, and it will give you the average velocity, right? Now another term comes instantaneous velocity, velocity at a particular instant. Suppose at we take a particle over here, consider the particle is here at t is equals to t, and at this point t plus delta t, okay? Again instantaneous velocity is equals to velocity is equals to limit delta t tending to 0 delta s by delta t, okay, which becomes ds by dt. The rate of change of displacement with respect to time will be called average velocity, okay? So we have learned average speed, instantaneous speed, velocity, and instantaneous velocity. ds by dt is also referred as the slope of the curve. That means That means if this point, if delta t tending to 0, then this point will coincide with this point, and we will get a slope which is ds by dt. Okay. Now next please. Now average acceleration and instantaneous acceleration. Okay. Now we will draw a velocity time graph. And again take a curve A and B. Now join these points with the origin. This is OA. OB, okay. Then average acceleration is equals to change in velocity VB minus VA divided by T2 minus T1, where T2 is the time at which the velocity is VB and T1 is the time at which the velocity is VA. T2 and this is T1. Okay. Again we consider this in the same way. Time t on this curve, a curve where velocity is there. T and then t plus delta t. Okay. Now instantaneous acceleration is equals to acceleration is equals to limit delta t tending to 0 delta v by delta t. So we can write instantaneous acceleration as tv by dt. Okay. Or we can also write as double derivative of displacement. Okay. Now one interesting part is that VT curve, area under the VT curve gives the total displacement. Okay. Now we are clear with average acceleration, instantaneous acceleration, and average speed and instantaneous speed. Now we will go for another topic, which is motion in a straight line. Using these formulas, we will be deriving the motion formulas for motion in a straight line. Okay. Now what we have learned, that S is equals to v is equals to ds by dt and a is equals to dv by dt. Because the coordinate is there. This is y-axis, this is x-axis, positive x-axis. You will assume that particle is moving in a single straight line. So positive x direction may be treated as the equation where the particle is tracing the straight line. So equation for straight line motion, we can write it dv by dt is equals to a, is dv is equals to a dt, and this is true only when acceleration is constant. Now integrating dv from initial velocity u to final velocity v, and the time dt where time goes from 0 to t seconds. From 0 to t seconds the velocity v changes from initial velocity u to final velocity v. After integration we will be getting v minus u is equals to at. So we get here the first equation, v is equals to u plus at. This is the first equation, okay. Now next page. From the previous equation, v is equals to u plus at. What we can write? This can be written as ds by dt is equals to u plus at. Okay. Now ds is equals to u plus at into dt. Where we can write u dt plus at dt. Okay. Now we integrate. Suppose in time 0 to t, particle has displaced from 0 to s. ds is equals to 0 to t u dt plus 0 to t at dt. So what we get here, s is equals to ut plus half at square. So here we get the second equation of motion under straight line. Okay. Now we will derive the third equation. V is equals to u plus at was there, right? Then V square will be is equals to u plus at whole square. Now this becomes u square plus 2uat plus a square t square, okay, is equals to u square plus, take out common as 2a, when this becomes ut plus half at square, okay. Now from the second equation, this can be replaced as s, so it becomes, so v square is equals to u square plus 2as. This is the third equation, right? So we have deduced all the three equations of motion in a straight line, right? Now next, we will study free fall, that is motion under gravity. Okay, for motion under gravity, let us have a small understanding that initially we took motion in positive x direction and in y direction, right? Here, in case of motion under gravity, if an object is thrown upwards, it moves up till its velocity reaches 0, then it, and if you drop a stone from a cliff, then it travels like in a vertical direction. That means here motion under gravity, the motion is in the positive y-axis. Okay, so first law, let us understand. Here is the motion wherein positive y is considered to be the direction of motion and acceleration in positive y, because acceleration due to gravity is acting downwards. So acceleration will be replaced by minus g in all the three equations. So the three equations becomes v is equals to u, a is equals to minus g, gt. Then s is equals to ut minus half gt square, where g is acceleration due to gravity, and v square is equals to u square minus 2gs. Okay, initially we derived the motion in a straight line or straight line motion. We considered the direction of motion of the particle in positive x direction, and the acceleration is also acting in the positive x direction, that is a. And now in case of motion under gravity, the particle moves in a vertical direction, that is, we can say that it moves in the positive y-axis, but the acceleration is acting downwards, whose value is g. So to make it in the direction of y-axis, we make it as minus g. Okay, so this is the motion under gravity. Okay, in next chapter we will be dealing with motion in a plane, projectile motion. First I will explain how motion in two dimension can be studied, and then after having understanding of motion in two dimension, we will switch over to the projectile motion, and subsequently we go for numerical examples. Okay, hope you enjoyed the lecture. Thank you.